Hello everyone, today is February 17th, 2023, and yesterday I just learned this new type of sort, Radix Sort, myself. That's a complete new sort algorithm for me, and this is the type of non-comparison based sorts. So I just learned this one. That's basically have the idea the sort by the digits. Okay, let me read this. A problem we encountered with the counting sort is that a count easily handles strings where the alphabet size could be unconstrained. Additionally, when the maximum value of the array is extraordinarily large, counting sort will lose its appeal since the additional memory overhead can cause things to slow down quite a bit. Radix sort is an extension of the counting sort that handles this problem. It works well with collection of the strings and the collection of integers, especially when the maximum value is large. There are a couple of variations of the radix sort, but let's focus on the least significant digits radix sort. Okay, I think that below the context will explain what's the radix sort. They gave you an example right here, and they just do sorting the last digits. Here, that will be the third digit of each numbers. That will be the 6666317. Note here for each sorting, that will sorting the each numbers from the whole. From the whole numbers. And after that, they will sorting the second digits and the first digit. After that, they will get the sorted. Okay, here the example. For here, they try to get this one, and if there's some digits less than the maximum of each other numbers, they start leading with the zero. That making sense to don't change the value of the numbers. And here, when I get this example, they do the last four digits, and they just sorting all the numbers, not only that digits. That also makes sense. We don't want to change the numbers value itself. But let me leave my question later on. So after that, they will do the sorting similar things again 4 times, and that's complete the sorting. Okay, so as you know, let me do this. Okay, as you know, the non-comparison based sort is really good and suitable for these one-digit comparisons. We don't compare each one, we just counting for each values here. What's the what's the how many zeros, how many 1, 2, 3 in this sorting arrays. Then we just read from the 0 to the 1. From the 0 array to the nice arrays to get how many ones, and that's sorting as is. And for the implementation, I'm thinking how I could handle and do that for the non-pair comparison. I just have an idea here. Let me show you. Okay, let me restart this one to activate my tablet. Okay, so one more thing. Let me write down very quick for this. I move this one out of Windows, so I could copy the value right here. Okay, so similar things. For example, that will be the 0, 2, and 4, 5, 1, and whatever that is be. I think that will be fine for whatever. I just gave you an example how I implement the one. So as the array, there will be the index for this one. That will be the 0, this one for the 1, and this one for the 2, this one for the 5, and this one for the 4. Okay, so for the non-comparison sorting, we will read the array each one, and for the additional extra space, we will compare this one. So this is the 0, 1. There will be the integer array for that. 2, 3, 4, 5, etc. to 9. That's all one digit. So from thinking the search the one, that's the one. So we save the index here, not the 0. So the index will be here 0. And another one is the 2. We just search the 2 and we got 2 here. Okay. And for the 4, number 4, we just go to the index 4 to save the index. All the way, that's the index save to the array. Okay. And the numbers 5, we just searching the 5 array and save the index right here. Okay. And the last one will be the 1. Okay. If that's another array, for example, blah blah, and that index is 5, so we just searching to this one and put right here, and it's indexed here. Okay, after that we will read the index right here, so the similar things will do the things right here. Okay, so like I know that's I put 0, that's the index right here, right? So that will be 0, 1, 2, 3, 4, 5. So I will put the original 1, 0, 0 here and 0 here. That's from the 5. Okay, from this one. 2 seconds. And I will put the 1 here, 2 here, and 4 here. That's the exact value right here, and 5 here. So that means 5, yes. So that will be sorted the array, whatever the following digits. That means that what the non-comparison happens from this Radix Sort implementation. Okay, back to the sorting itself. That majorly have the implementation in the Python and Java. And the time complexity things, so that's I mean the time complexity is really based on the different values. So let's see. So the n, well, the numbers n is always the size. So the okay, that's the size with will be the n, and you know the n, and the k will be. Let me see. The render time of the LSD Radix Sort requires a few parameters. That the w will be the maximum digits of the length. So for my example, that will be the 4. And the n will be the size of the whole input array. And the k will be the alphabet size k. So for here, that will be the 9, since that's the 9. So in the case of the digits that contains 10, sorry, that 10, 0 from to the 9, that will be a 10. My mistake. And so the whole one will be, let me see, so that will be the n. We need searching for the each digits. We definitely need the digits w times by n. And since we need searching the all the one to the that one, why we need k times n for the time complexity? I don't understand that. Let me see. So for the first line, we just need searching 1 times, 2 times. Yeah, otherwise that will be switch. Okay, that's one. Oh, that's direct. He is thinking maybe they say it's the W, right? That's not W. They say it's the K. The K for the alphabet size. Here will be the 10 for the digits. So each time that will be searching that's the index of the size. Why we need a searching? Oh, whatever. So that's the question. My question. I understand why the time complexity will be the length of the digits, the maximum digits, times the length of the array plus the alphabet size. And the extra space will be the n plus the k alphabet size. I understand that part, no problem. Since they need to switch one back here, they need additional k n and plus this index array for the size. That's all will be 8. Let me see. Hmm. Yeah, that's the one. And another thing will be the MSD, the most significant digits. Radix Sort. I don't know how that happens. Yeah. I probably need to think about how the time complexity will be the plus the k, the alphabet size later on. But so far, that's my idea for the whole Radix Sort as is. Yeah, thank you for watching. See you next time.